All right, guys, this is going to be the recording for Magnetics Fields 1.6, and you can see I have a little co-star right here who needs to sit on my lap while I record this, I guess. But for this lesson, we investigated magnetic field lines a little bit further. This is also the last lesson of chapter 1, so we kind of wrap up a few of the main ideas that are needed for this unit. And so the first thing that we did is completed slides 16 and 17 in the notebook. There was an activity in Canvas and an exit ticket. I put a little note here to remember that on Friday there is a chapter 1 quiz, and those Cornell notes that I provided you on Monday and Tuesday. You had there was links to video recordings in the module on Monday or Tuesday for you to use to get your Cornell notes filled out, and I advised you to do that then. That way you had them early in the week to use to kind of review. I also put this down here because you have slide 11 of your notebook, and these doodle notes were in there, and we actually had skipped that, and so I gave this to you so that you could get that part filled in, and there's some good information in this. Obviously yours is not going to be in color, but I thought this was a good little example for you to have in there. And then as always, these slides are down here for you to kind of go through if you need them. So on slide 16 and 17, once it loads here, you can see that it's pretty much filled in from earlier, as I have cats climbing all over the place. Oh, he's back. So, oops, go back to this one. So this was slide 16, and on this one, you will see that we filled this in. All that was on it before was just these two pictures, and in class we talked about how Model A represented two magnets that were repelling. I'll actually write that on here. So Model A had repelling magnets, and then Model B had attracting. I'll put that down here. Just to kind of keep track of that. And so those were what those magnetic field lines were showing us. And then we put these magnets here, and we took the arrows, everything from over here, and put it to show what would happen after the release. And we know that opposites attract and likes repel. So we have like sides on each, and those are repelling and going away. And then down here on this one, we have opposites attracting and coming together. If you have issues with the slide, I know a few people did. There's a few ways. If you drag and drop onto this slide, sometimes it was disappearing because it was actually going behind the picture. You can try copying. So if you right click, copy, and then if you paste over here, it'll pop back up over here, and then you can drag it and drop it. For some reason that worked, but that was kind of a solution. It was acting weird. And then down here, the first question asked how we identified where the poles of each magnet should be. And this is kind of what we talked about, the magnetic field lines. We know that Model A showed the field lines that would be repelling, and then Model B showed field lines that would be attracting. And then down here, it then asked us how we decided where those things should go. And so if the magnets are repelling in Model A, we know that the poles needed to be lined up with like poles. So N north and north together, and south with south together, because like sides repel. And then for Model B, the magnets had to attract, so that means that our poles needed to be on opposite sides. So north with south, and same north with south. Okay. And then on slide 17, what you had to do was there is 3 pieces of evidence. So there's one piece over here, right here, and then evidence 2 over here, and then evidence 3 is over here. And you have this claim here. So the magnets in the launcher were misaligned during the Tuesday test launch, causing it to be slower than expected. And so this goes back to the scenario that we investigated in the beginning of the unit. And so that is kind of coming back to this image that you saw in the beginning of the unit. And so their goal was to launch at 100 meters per second. And you can see the first launch on Monday, it was 4 centimeters apart and it launched at 80. And then Tuesday, they moved it closer, so it was only 3 centimeters apart, launched at 90. Wednesday, 2 centimeters apart, launched at 120, so it skipped a lot and it missed the goal of 100 meters per second. And so, are any of these misaligned though? That's something you're going to have to look at. And then evidence 2, this is aligned launcher, what it should look like. And then this is a misaligned launcher. So you can use this evidence to kind of go back up here and say, are any of those misaligned? Are they lined up? And kind of what you think. And then if you look over here, evidence 3, these are magnetic field lines, and you can kind of look and see those. And so what I asked you to do is you are making 2 observations on each of the pieces of evidence. And I gave an example. So an example of an observation that you could have done over here would be the closer the magnets got, the faster the launch, because we saw they moved them closer and the speed increased. And so 2 for each, and then you're going to say yes or no. Does it support the claim? Just a quick yes or no, because down here you're actually going to explain a little bit more, and you're going to type in 3 to 5 sentences how the data over here, all those evidence, cards support or maybe don't support, because you could say they either support the claim or refute it. And to refute means to disagree or to prove it wrong. And so I gave a few hints here, and we talked about how in order to launch, like we have been talking about, we need the the like sides, because we want to repel the magnets. And in order to launch it, they have to repel. So we want like sides lined up. And then down here, we saw that this was what a misaligned magnet looked like. And we kind of were thinking, were there any magnets in our evidence 1 that were misaligned? And so that was kind of the hint that I gave for that. And so those are the 2 notebook pages. And then, like I said, there is an activity in Canvas. When you click into that, it's going to give you directions. And I directed everyone to go and try to do that on their own. I'm actually going to reference that activity to begin our next class next week. So on Friday, we're going to have a little chapter 1 quiz, and then next week we'll start chapter 2, and I'm going to reference this activity to start. And so I want you to try it on your own first. It has to do with the simulation, and you're kind of using some of the magnets to deal with different types of energy. So a few of our ideas we've been learning are kind of coming together a little bit. And then there is an exit ticket, just a couple questions to check your understanding. And so if you get these 3 things done, make sure you have your Cornell notes done and the doodle notes. And that is it. Chapter 1's over.